Hello friends, in this video we are going to study the types of boundaries which are called as smooth according to hydrodynamic concept. So, which are hydrodynamically smooth and which are rough are going to be studied in this topic. So, let's move on to the video. I am talking about the boundaries, that is the edges of the plate. So, if I am considering the flat surface of a plate, then it is not necessary that that will be smooth. So, depending on the various conditions, we will call the plate as smooth and rough. So, if I talk about the surface of plate, say this is the surface, and these are the undulations which are shown by hatched line in the figure. So, these are having some height from the base or flat surface. Practically speaking, both the surfaces are having some roughness, but hydrodynamically talking, I can differ the two types of plates. We know that in boundary layer, this is laminar zone, this is transitional zone, and this is turbulent zone. In turbulent zone, there exists a laminar sublayer. Laminar sublayer is that zone in which flow velocities are very slow, hence all the layers are parallel to each other. So there is not exist any disturbance between the travel of fluid. So if I talk about separate layers, say this is first layer, second layer, third layer, they will not get mixed in each other. So it means that there is not any chance to form a wake or disturbances in laminar zone. So this laminar sublayer zone plays very important role to decide whether that portion of plate is hydrodynamically smooth or rough. If the undulations are below laminar sublayer, it means that they are not disturbing the stresses, they are not disturbing shear stresses beyond this laminar zone. So that type of plate is called as smooth boundary. And if the undulations are having height more than the laminar sublayer zone, if the part of plate is encroaching beyond the laminar sublayer zone, then it will create some disturbances, some wake formations. So that type of plate is called as rough boundary. So when average depth K, I will denote it with symbol K, is less than laminar sublayer of surface del, then called hydrodynamically. See, this is not actually smooth, but it is according to behavior of hydro, that is fluid, it is smooth. If it is not, then called hydrodynamically rough boundary. So in case of these rough boundaries, the eddies are formed. I am showing the part of eddies, this curved portion. This curved portion is nothing but the entry of fluid into the region of laminar zone, so that is called as eddies. So eddies formed outside laminar sublayer try to penetrate in laminar sublayer. But cannot reach to surface in case of rough boundaries. Eddies reach to surface, hence called rough boundaries, and obviously hydrodynamically. So it is very important what will be the thickness of laminar sublayer zone. Then for that purpose various scientists have practically taken some values, and their results are, as per the scientist is Nikudse, whatever will be the pronunciation. So according to this scientist Nikudse, when k upon del value, k is the laminar sublayer zone thickness and del is the laminar layer thickness, is less than 0.25, that is called as smooth boundary. Practically speaking, if this is first zone, this is transitional, this is turbulent, this is laminar zone, say this is total 4 centimeter and say this is 1 centimeter, so this ratio is 1 upon 4, that is 0.25. If this k value is less than 0.25, if thickness of this layer is less than 1 centimeter in case of 4 centimeter thick boundary layer, then in that case the boundary will be called as smooth boundary. When k upon del value is greater than 6, it will be called as rough boundary. And when it ranges from these two values, that is 0.25 to 6, then it is called as transition boundary. If I want to talk about Reynolds number, then we can also conclude some results as per Reynolds number, U star into k divided by nu should be less than 4 for smooth boundary. This is the velocity of flow, k is the thickness of laminar sublayer, and nu is the dynamic viscosity, kinematic viscosity. This is the first result. Second result is U star into k upon nu is greater than 100, called as rough boundary. And third, U star into k upon nu between 4 to 100, called as transition boundary. That's all. Thank you.